Okay, so we are continuing our talk of Big Java, Chapter 2, and this is the second part of Chapter 2. A lot of this area is overlapping with the CS2, which is prerequisite for this one, so I'm not going to go through them in detail. And you can see something similar to C++. So if you don't know it, you can review it. It's not that much difference in certain of these things. So one of them is the variable. How is it constructed? What is it doing is exactly like C++, the data types that we have. So you don't know it, review it. If you know it, you can skip over it. I want to go over these names because your C++ changed it from the last version, but we want to go over it to be sure we are all on the same page. So we're going to have names for the variables so we can identify them. And the way that we're going to do it, there is some convention that Java is using, and we're going to go with those convention. That's going to make it easy for everybody to understand it. So in general, we can start with underscore or a letter. After that, we can have characters. We can have letters, numbers, or underscore. So we can mix them up. So traditionally, what we were doing, we were using the underscore between the words, so to make it easier to read. Here, we are using something called Camel Case. But you got to be sure, I'm pretty sure most of you know, that we don't have any special characters in here, just the letters, numbers, and underscore. I'm pretty sure most of you know, coming out of the C++ class. So what we're going to do is we're going to use the uppercase letter to denote word boundaries. So remember, we're going to have some explanation. So no single character variable. Your variable is going to describe what is it about. And then we're going to have it uppercase for each word that we have. So miles per gallon. And what this is called Camel Case. So that's why we're going to be going through this. So names are case sensitive. And of course, we cannot use reserved word. Those are I'm pretty sure you know about it. It's the words that the compiler is using to understand certain things like data type, like class. So the Java convention that we're going to follow is that for the variables, we're going to start with lowercase. For classes, we're going to start with uppercase. So when you see a name, you automatically know if this is for the class or this is for a variable. And when we learn more about it, then we're going to add our stuff in there. Next part is about the comments. So C++ is using 2 // and of course /* is coming from old-fashioned C language. So we have both of them here for Java, just like you have it in C++. The 2 / is from this point to the end of the line, and if I have a block, then I can use a /*. We want to explain what we're doing. And of course, if you're explaining too much, that means our code is not good. It's very complex. If we are not explaining enough, that means the next person, can be myself, it's not going to be able to follow the code. So we're spending 4, 5, 6 days to figure out a block of code. That is not a good program. Assignment is the same as C++. I'm not going to go through that. So how do we assign something from the right side to the left side? calling methods. Remember, the methods are the same as functions in C++. So when we're creating objects of the same class, all the methods going to come to each object. So we have multiple objects of the same class. Each one of them is going to have different data, but the methods are the same for all of them. So we talked about println and print. That's coming in from printer stream. So again, back to this picture, we have the name of the class, we have the data, and we have our methods. So when we're creating an object, we're going to enter the data for it. This method is going to be available. That's why object-oriented design has been very important aspect. We don't have to recreate it. We're going to create it, and then based on that class, we're going to create objects of that class. So if you're looking at the string class, remember the class starts with uppercase character. That's the class. And when we have a variable name, it starts with the lowercase. So we have a method called length that's going to return the number of characters that we have. That is part of my string class. So when I create an object of a string, I can execute that method. And it doesn't matter which object is it. I can create 2,500 of the object from the string. Each one of them is an existence of a class. The manufacturing is going to make a lot of cars. Each car is different than the other one. People are deriving different one, but they can have the same template. So Toyota Prius is going to be the same shape overall, and they can have the same look, but they are different objects. So we're gonna have a class name over here. We're gonna have the class name over here. We're gonna have a variable name over here, and then we're gonna put something in there. Now we're gonna create another variable, and you have to pay attention to this. I know when I first started Java, I didn't like all this typing, but it is very clear of what the variable is supposed to do. Number of characters equal the greeting, which is this one right here, dot length. So it's going to go to this object greeting, which is type of class. It's going to count all these characters, and it's going to return the value for it. Another example that the string has a method is called toUppercase. And toUppercase is going to change all the characters to uppercase, and it's going to return another object. It is not modifying the current object. So it's going to build an object, and it's going to return that. So the original one is not changed. The new object is changed. And that's something from the software engineering point of view, that when we have object as our parameters, sometimes we don't want to change the original one most of the time. We want to preserve the original one because we may need it somewhere else. We're just going to create a new one with the changes, and we're going to return it. We're going to spend some time on clearing those things out. So public interface means, how do we communicate with this object? What do we have to communicate with this object? So when I am sitting in the car, all the controls in the car is a public interface. I can sit in there. I can look at the dashboard. I can drive it. I can clean it. I can do the things with the car that's happening. So if I push a start, then the engine is going to stop. That is my public interface with the engine. When I push the brake, the car is going to stop. That's the way I am interfacing with stopping the car. And of course, private implementation of those things, it's not my concern. How the engine is working, how the transmission is working, how the brake system is working, how the window system is working. It's not my concern. It's just how I'm going to be using them. Just tell me how to use it. So a string class, we just saw two methods. One is the length, one is to uppercase. Of course, we have a lot more than that. So these are the methods that we're going to be using in a string. So all the methods that we have is called public interface. That's the way the object is communicating with public, with outside. So if we're talking about my house, the outside of my house is public interface. How they're going to get into my house, my front yard, the windows that I have outside, the paint that I have outside. So all those things are the public interface. So if I give the key or I have the remote access to the front door, I give it to somebody, they can come into the house. That's how they interact with the house. Okay, so when we are building objects of a class, remember, we cannot use them, we cannot use the class till we build an object from it. So we're going to build the object, and each object, even though they look and feel the same, they are different things. So if we have two Toyota Camry, they are totally different cars, even though they look the same, even though they function the same, behavior the same, but they are totally different objects. And that's what we do in the program. So in this case, I have two different objects of a class string. One of them has a data, hello. The other one has a data, Mississippi. So the data is different, but the methods are the same. So when I call the lengths on this object, it's going to give me the lengths of what I have in this object. When I call the lengths of this object, it's going to give me the lengths of this object. Same thing with two uppercase, and same thing with other methods that we may have. So every time we call a method, just like we did it in functions, we may or may not have arguments. So what's going into it can potentially be the argument or parameters in there. So println in this case is accepting a string. So that's what's coming into it, and it's going to do something about it. And you can see that there is no value coming out of it. So if I go to a tailor and I say, sew me a suit or a pants or a jacket or a shirt, what arguments do they need? What is it that they need to build me, sew me a jacket or a pants? And what is it coming back out of it? So when we have a method, there are things that we need before we execute the method, and there is going to be something that that method is going to do for us. So you're looking at, let's say, manufacturing. There are going to be some raw material going to my final manufacturing, and it's going to build something, and it's going to return the value. So for a car, they need metal sheet. The metal sheet goes in there, they build the car, and the car coming out of the manufacturer. So same thing goes with the tailor. The customer measurement is important. Fabric, what kind of a fabric do I want? And that's what they need before they execute the sew. And after they do that, the return is going to be the garment, whatever I ask for, a pants or a jacket or a shirt. That's what's going to come out of it. So sometimes we have multiple arguments, sometimes we don't have no argument. So for example, the lengths didn't have any argument, but we still have to use the parentheses. So we talked about return value in the previous course. We're just going to return something. We're going to store that somewhere. I'm not going to go to the detail of this. So one of the things I like about the return value methods or function is you can use them as a parameter to another method or function. So basically what happens is when you call this greeting.lengths, is going to be replaced by the return value. So let's say the length is 15. When I call greeting.lengths, it's going to return 15. So this whole thing is going to be replaced with 15, and the 15 is going to be passed to println. So it's going to execute the method, it's going to get the return value, and it's going to replace the whole thing with the return value. Now I can put that as a parameter of another method. Okay, so we have a method called replace. So when we're calling the replace method, it's going to take the, remember, it is belong to this object. So I have an object of a class, and then I am creating a river that has, so the string class, I'm going to call it river, it's going to contain this. This is my data inside that class. This is the method that belongs to the class. So when I create an object of a river, it's going to have this method come to it. All those methods going to come to me. I don't have to write them. It's already available. So when I call this, it's going to go in there and it's going to look for this and it's going to change it for this. If it's multiple times in there, it's going to do multiple times. So when it does that, it's going to return another object. It is not changing the current object. It's going to return another object. So in this case, we're going to take the new object and we're going to put it on top of the old one. If I don't put it on top of the old one, then of course it's not going to replace the old one. So it's going to construct a new one. It's going to change ISSIPP with OUR. It's going to create this new object that the data is going to be misery, and then it's going to return that object. It's going to talk about the reference of the object later on. And then you can put that object somewhere else. So when I call the river.replace, I can pass that. Remember, it's going to return an object to the parameter in the println,